Welcome. We're going to start our discussion on a brand new topic, that's stoichiometry. Now, the components that make up stoichiometry is probably not going to be new to you. As you would see when we begin to talk about the concept, you would see that there's a lot of knowledge that you have learned so far is all you really need. And you're just going to use it in a different way to make sense of what you're trying to do. So without further delay, let's get started. Stoichiometry, of course, it's a new topic. So what is stoichiometry? When a system is balanced, what do I mean by system? Well, system could be anything. For our case, it could be a chemical reaction containing reactants and products. Okay, when that system, when you see your reactants go to make products, or sometimes you have two-way reactions where products could go on to make reactants again, but we call the reaction itself as a system. When the system is balanced, please do not confuse the word balanced for equal. Okay, balanced does not mean equal. Okay, chemical reaction is balanced perfectly enough when the total reactants equals to the total products. That's a possibility, but don't assume that balanced itself means equal. Okay, with that said, I have tried my best to make this concept, the whole idea of stoichiometry, simple as possible. Now, simple doesn't mean spoon feeding, or it doesn't mean cookie cutting type of problems. Okay, I do want you to understand the idea of stoichiometry, but we're going to primarily focus on two different concepts, because if you know that, I think you really know the idea of what stoichiometry stands for, and that would be when one of the reactant, you could have 10 reactants, okay, making 25 products, it doesn't matter. If one of the reactant is limiting, then that type of problems will have a certain logic. And then when one of the reactant is in way to excess, isn't that the same thing as saying when one is limiting? Yes and no. Okay, the way we approach things in chemistry is different. Okay, if you haven't got that idea so far, then you're probably missing out. Okay, it sounds kind of the same thing, but there's some subtle differences which we will see. So the first type of concept is limiting, which is usually what is called a default type of problem. And in the second case, when it's to excess, you must be specifically told which one of those reactant is excess. Now, when a reactant is limiting, it does not have to be, you do not have to be notified of it. You will figure it out yourself. Whereas when a reactant is in excess, you will be told precisely, hey, this is excess. Does that make sense? So when a problem doesn't specifically say something is limiting, it is your job to figure out which one's limiting, and then you work your problem out. The second case is, it's easier, where you'll be told specifically which one is excess, and you work your problem that way. All right, we're going to look at those two things. And something I found fascinating teaching chemistry for a long time now is sometimes people can solve a reaction going in one direction, but they can't just seem to do it backwards. It's like, you can bicycle your pedal at a gym forward, and you're able to do it backwards as well without any effort. Well, that does not seem to be the case when it comes to learning chemistry. So within these two concepts, I'm going to actually show you how to do it forward and also do it backwards. All right. So I have tried to keep the amount of time you learn this is to a minimum, but I think you will get what you really need to know about the idea of stoichiometry in the short span of time. Okay. Now, before we actually get in, and I want to wrap this quick introduction video, is what concepts do I need to know from a prior knowledge database? Well, you need to know how to go from grams to moles, moles to grams, ability to balance a chemical equation, and be able to determine the molar mass of a formulae. You've done all this in the prior concept learning process. So you should know these terms, and if you have not, then you need to go to the video that talks about grams to moles or moles to grams. quickly watch it, and then come back and continue watching the videos on stoichiometry. Does that make sense? So what key term or terms do I need to remember when dealing with stoichiometry? Now, these are terms you may not have heard prior. So these are the terms you will learn specifically for this concept of stoichiometry, which I will introduce each one of these as we do a particular problem or a particular concept. All right, and that would be percent yield, mole ratio, limiting versus excess. These are terms that are by default screens stoichiometry. All right, so you see how I have narrowed down the concept to just few words. Okay, instead of me lecturing for half an hour about each one of these, I have tried to cover some of these previously. Some we're going to learn, so I've made that distinction. So if you're comfortable with all A, B, C, D above, then you're more than ready to learn stoichiometry. So stay tuned for videos on the concept of stoichiometry.